All right, today we're going to tackle a really core algebra skill, solving radical equations. Now, this isn't just about plugging in numbers. See, there's this kind of hidden trap baked right into these problems, and learning how to spot it is going to make you a way smarter problem solver. So, let's get into it.
Here's the game plan. We'll kick things off with the absolute basics. Then we'll jump into the core strategy you'll use almost every time. After that, we'll level up to some tougher problems. I'll expose that hidden trap I was just talking about, and then, finally, we'll cover the one golden rule you absolutely need to know.
Okay, let's jump right in. First things first, what in the world are we even talking about when we say radical equation?
So, the key word here is radicand. That's the whole secret. A radical equation isn't just any old equation that happens to have a square root in it. No, it's one where the variable, the x that we're always hunting for, is literally trapped inside that radical symbol.
Here's a perfect, simple example. See that x? It's not next to the root. It's right there, underneath the square root sign. That's the feature that makes this a radical equation, and that's what creates the unique puzzle we need to solve.
So how do we get that variable out of there? How do we free it? Well, we need a core strategy, a kind of repeatable game plan. And that whole game plan boils down to one word: isolate.
This four-step process is going to be our playbook. Step 1, get the radical all by itself on one side of the equation. Step 2, raise both sides to a power that'll cancel out the root. So for a square root, we square both sides. If it was a cube root, we'd cube them. Step 3, solve whatever simple equation is left over. And step 4, and trust me on this is the most important one. You have to always check your answer. We'll see why in just a little bit.
Okay, let's put this into practice. To isolate the radical here, all we have to do is get that -4 over to the other side. So we add 4 to both sides, and boom, the square root of x equals 7. Step 1 is done.
And now for the magic trick. How do you get rid of a square root? Well, you do its opposite. You square it. But of course, to keep the equation balanced, what you do to one side, you've got to do to the other. So we're going to square both sides.
And just like that, the square completely cancels out the square root, and the x is finally free. On the other side, 7 squared is 49, so it really looks like our solution is x equals 49.
But we can't just call it a day until we do step 4. Let's plug 49 back into that very first original equation. So, the square root of 49 is 7. 7 minus 4 is 3. Does 3 equal 3? You bet it does. Checks out perfectly. The answer is definitely 49.
All right, so that was a warm-up. You've got the basic idea. But what happens when the equation decides to throw not one, but 2 radicals at us?
I know, this looks a lot more intimidating, right? It just feels like it should be way more difficult to solve.
But here's the secret, and I absolutely love this quote from Hamlin Math. It's not actually more difficult, it's just longer. We don't need a totally new playbook here. We just have to run our same 4-step play more than once.
And here's what that looks like in practice. You just focus on one radical, isolate it, and square it away. That'll probably leave you with another radical hanging around. No big deal, you just repeat the process. Isolate the one that's left and square it away. It's just a rhythm. Isolate, square. Isolate, square.
So, we have our strategy, but now we really have to talk about that twist I mentioned at the very beginning, because there's a hidden trap in this process that can catch you completely off guard if you're not paying attention. This trap is called an extraneous solution, and it's such a weird idea. It's an answer that you get by following all the rules of algebra perfectly, but it's still wrong. It's like a phantom solution that looks totally real, but it's an imposter.
So where do these fake answers even come from? This quote here explains it perfectly. The act of squaring both sides, that's the culprit. Just think about it for a second. The simple equation x equals 2 has only one solution, right? It's 2. But if you square both sides, you get x squared equals 4. Suddenly, that new equation has 2 solutions, 2 and -2. That squaring step can literally create an answer out of thin air that wasn't part of the original problem. Let's see this trap in the wild. If we work through this equation using our isolate and square strategy, we eventually get 2 possible answers, x equals 5 and x equals 12. Both of them were found using totally valid algebra. But the question is, are they both true solutions to the equation we started with?
This is where our check step puts on its detective hat. First, let's plug in x equals 5. The square root of 5 plus 4 is the square root of 9, which is 3. Add 5 to that, and you get 8. Does 8 equal 8? Yep, perfect. Now let's try x equals 12. The square root of 12 plus 4 is the square root of 16, which is 4. Add 12 to that and you get 16. Wait a minute, 16 does not equal 8. And there it is. That's our extraneous solution. The algebra led us right to it, but the check revealed it was an imposter all along.
And all of this brings us to the most important part of this whole explainer. It's the simple, powerful golden rule that lets you sidestep this trap every single time.
This is it. That's the golden rule, the entire secret to mastering these equations. Checking your answer isn't just a good idea or something you do if you have extra time. It's mandatory. It is the only way to know for sure if you found a real solution or one of those fake phantom ones.
So why does this one step matter so much? Well, we know the act of squaring can create these false solutions, so checking is your filter. It's the only tool you have to separate the real answers from the fake ones. It's what turns a maybe this is the answer into a yes, this is definitely the answer. Honestly, it's your secret weapon.
So I'll leave you with this question to really let the idea sink in. We know that squaring an equation can create these phantom solutions, but really think about why. What is it about that one simple operation that has the power to introduce a solution that just wasn't there to begin with? If you can answer that, you've truly mastered this.